In this last video, we're going to take a look at the difference quotient. And the difference quotient is going to be evaluated by this expression. So it's going to be f at x plus h. So we're going to start by substituting x plus h back in for x minus f at x divided by h. And then we're going to simplify whatever the resulting expression is after we go through and simplify the numerator. This is one of the most fundamental sorts of formulas going forward, especially for those of you that are going to take calculus. And we are going to take a look at this formula a little bit later with respect to some rates of change. But for right now, we're just learning how to find the difference quotient. So we have three examples, and let's start with a fairly basic one. So we have 3x plus 1. And what we're going to do is we're going to start by substituting first x plus h. So we get 3 quantity x plus h plus 1, and then minus f of x, and that's going to be the original function, 3x plus 1, and we're going to divide all of that by h. Okay, so this is our f at x plus h. This is minus f of x, and then divided by h. So again, all we're doing is everywhere we see an x, we're substituting x plus h in right here. Now, we're going to simplify this by distributing the 3 and then combining like terms and also distributing the negative to the 3x plus 1. And then we might be able to simplify after that a little bit more. So resulting is going to be 3x plus 3h plus 1. Right? So we took our 3, we distributed here. We're going to take the negative. We're going to distribute those two to get negative 3x minus 1. And we're going to divide that by h. Usually when we perform the difference quotient operation, a lot of items in the numerator are going to cancel. And so notice that we have a 3x and a negative 3x. We have a positive 1 and a negative 1. And so this just simplifies to 3h over h. And then we could just simplify this by canceling the h's. And so the difference quotient is 3. In this example, what this really means is that the rate of change of this function is always going to be 3. Which makes sense because it's a linear function. And in the next section, we're going to see that the slope of this is 3. All right, but this is just a way to verify that. So anyhow, a secondary example. Now, this one's a lot tougher because we have a lot more algebraically going on. Okay, and recall that our difference quotient, f of x plus h minus f of x divided by h. And so we're just going to substitute back in. So anywhere we see an x, we're going to substitute x plus h to begin. All right, so this is going to be 3 quantity x plus h minus 2 x plus h squared plus 4. Then we're going to subtract the original function, which was 3x minus 2x squared plus 4. And then finally, we're going to divide all of that by h. All right, now to simplify this, we're going to have to do a number of polynomial operations, particularly right here, to simplify this expression, or to expand it, actually. We know that certainly we can distribute the 3, so that's going to be 3x plus 3h. The negative 2, what I'm going to do is I'm just going to leave that, and I'm going to write this as x plus h times x plus h. Remember, whenever we square something, we write the binomial, or square a binomial, we write it next to itself. And then we still have that 4 that's kind of lingering there. And then I'm also going to distribute the negative to all 3 of the terms inside the second bracket. So this is going to be minus 3x plus 2x squared minus 4. Now I'm going to FOIL this. Okay, and we still are dividing all of this by h, so we can't forget that. And by the way, we can start canceling a few things. Okay, so notice that we have a 3x and a 3x, those are opposites. And we have a 4 and we have a negative 4. So those are opposites. We can cancel those out. And so now we're going to get 3h minus 2. And now I'm going to do first, outer, inner, last. So we get x squared plus hx plus hx from the inner plus h squared. And then we still have a positive 2x squared. And we're dividing all of that by h. Now, finally, we could distribute the negative 2 and then maybe collect some like terms after that. Okay, so we're getting close to being done with this one, but it is a little bit more algebraically taxing than anything else we've seen. So we have 3x, or 3h, excuse me, minus 2x squared plus hx plus hx, I'm sorry, minus 2hx. I forgot to distribute the 2 to those, so go back. That's going to be minus 2hx minus another 2hx minus 2h squared, and then we still have that 2x squared that was lingering from the f of x at the beginning, divided by h. We notice that there's opposites of the 2x squared, so they cancel out. We notice that there's some like terms right here, and so we're finally going to get a simplified numerator of 3h minus 4hx minus 2h squared divided by h. And finally, to simplify this expression, we can break it up into 3 smaller fractions, or we could factor in h from the numerator. Okay, so I'll show you 2 ways of doing this, so that way, whichever way you prefer. So one way is to factor it, where you factor out a greatest common factor of h, and you're left with 3 minus 4x minus 2h divided by h, and then the h's would go away, and then this would be your resulting difference quotient. Or another way of doing this is write it as 3h over h minus 4hx over h minus 2h squared over h. And then each of those would simplify by a factor of h. So the h, and h, and then one of the h's would go away. And so we would be left with 3 minus 4x minus 2h. Either way, we still get the same result for both of those. But I just wanted to show you all 2 different ways of being able to simplify that algebraic expression. Never hurts to see the algebraic steps a few times. All right, so again, that was a little bit tougher than the previous. So lots of algebra going on with this, lots of bookkeeping. A third example, we have this h at x equals negative 2 over x. All right, and so again, remember our difference quotient. Okay, so I'm going to write it out again so that way when we substitute, we remember what this looks like. All right, so here's our difference quotient. And so we're going to start by plugging in x plus h. So this is going to become now negative 2 over x plus h minus a negative 2 over x. All right, so that's f of x, and then f of x plus h minus f of x, and then we're going to divide that by h. All right, now this is a little bit more difficult for us because what we have to do is we have to try to add the fractions in the numerator, and we have to get a least common denominator. The least common denominator in this case is going to be x times x plus h, right? And so what I'm going to do is I'm going to rewrite each denominator with the new least common denominator, okay? And I'm also going to simplify this double negative as well. And so now we get negative 2 over x plus h plus 2 over x plus h, and we're going to divide all of that by h. Now, we can't just rewrite the denominator without rewriting the numerator. And so what we do is we look to see from the first denominators to the least common denominators what's missing. All right, and so notice that we had x plus h, and we had x plus h, but now we have this new x in here. And so what I'm going to do is I'm going to multiply the numerator by an x to compensate. All right, so it's just basically like a fraction. Okay, whatever you multiplied to get to 1, you have to multiply to the numerator as well. And then notice to go from here to here, that now we have this factor of x plus h. So I'm going to multiply the numerator by x plus h. Okay, so again, just getting a common denominator, making sure that we're okay, being able to add these fractions together in the numerator, right? So now we're going to distribute and then collect like terms, all right? So if I do that, I get negative 2x plus 2x plus 2h divided by x plus h all over h. Okay, so what I did was, now notice these are common fractions, these two right here. And then I distribute the 2, all right? So that's where this 2x and 2h came from. And then I just melded it into one fraction in the numerator. Okay. Notice now that we have a negative 2x and a positive 2x, so they cancel out. And now what I'm left with is I'm left with 2h over x plus h divided by h. Remember, if you have a complex fraction, or in other words, a fraction divided by a fraction, you can multiply by the reciprocal of the second fraction. And so we can write this as 2h over x plus h times 1 over h. H's are going to cancel out, and then we multiply straight across. So we get 2 over x plus h is going to be our final difference quotient for this. Okay. All right, so hopefully that helps you out with some of the algebra. And I realize that some of the algebra is a little bit nasty, especially if you haven't seen complex fractions or some of the polynomial stuff. But these are the sorts of things that are really going to help us later in the course when we start solving more rigorous sorts of equations and being able to solve a little bit more rigorous inequalities. So that's all for this section. And then the next section, what we're going to do is we're going to start taking a look at linear functions and how do we build those sorts of functions and what are some of the properties of those functions.